Well, now I can say, welcome back to the shop. Hi, I'm Mark, and this is Incidental Information, or I Squared, as some have come to call it. Today, I'm going to talk about a subject that is near and dear to my heart, and I think a lot of shop rats are kind of fond of, and that's jigs and fixtures, especially those jigs and fixtures that perform a lot of functions and are a lot cheaper to build and more fun to make than they are to buy. I just recently received a catalog in the mail that, as I'm thumbing through it, I'm noticing jig after jig after jig of all single-purpose jigs and fixtures that I might use once and I couldn't imagine using again, and where to store them, and they're not inexpensive. So whenever possible, jigs and fixtures should hopefully be multi-purpose. Someone told me that there's 3 reasons to make a jig for any job. One, and probably the most important, is if the job is dangerous. If it's something where you don't want your hands near the blade or tooling, that you can build a jig to hold the part while it's being cut or machined, so much the better. So, dangerous jobs, make a jig. The other one is repetitive. Especially if it's boring, you don't want to pay attention, you have to continually take the same measurement over and over, and you're going to be doing it several times, make a jig. And the third reason is just for accuracy, repeatability, which is kind of the second reason, but a lot of times you need a certain ability to fine-tune something, and making a jig gives you that ability to eliminate some variables in your work. So with that in mind, here's some of the jigs that I've made that I really like. The first is the Crosscut Sled. Now, this is just a board with a fence at the bottom, and the fence swings, and I have pinholes. I have 1/4-inch dowel pins in this, so I can bring it up to 45. Well, actually, this is 60. I can bring it up to 60, or I can bring it up to 45. And it's very repeatable, very accurate. I have a guide in the back that sits in the slot on the top of the table saw, and that's my Crosscut Sled. Very reliable. There's a lot of people making Crosscut Sleds that run all the way across the blade and you cut right through them. For 90-degree cuts, those are obviously excellent. I wanted something that was just a little more multi-purpose, and this certainly does the job for me. And I can take this fence off completely and just hold my work against the board as I slide it through if I need some really strange cut. Sometimes I'll put a router pad under the work, between the work and this board. So that's simple. Next up is something very similar. I hang most of my jigs if they're not in the way. This is also a crosscut. This piece sits in the table saw guide slot, the miter slot, and this is my adjustable stop for a cutoff length. This is just straight 90-degree cutoff, but having this length which extends out over the edge of the table saw to hold my work with an adjustable stop comes in very handy. Now the stop, I'm coming close here, the stop is made with as a continuous dovetail, and the 2 pieces on either side are the same pieces of wood, and the small detail to notice is there's a screw coming through the bottom which just comes through a T-nut, Very simple. And that's what locks it in place. And then under the screw I have a little disc of metal that sits in there so that I don't mar this top piece when I slide it in. I have to do this upside down here so I don't lose my little disc. There we go. So now when I tighten my screw, I'm tightening down on that disc, and I'm not putting these little dimples in the you see that? These little dimples in here. So before I had the disc, I had this. And that made it difficult to adjust my positioning, because it would find the hole and go for it every time. Very simple, really not much to it. Guide slot, piece of wood on the back for guiding. And there you go. I'll hang this back up. Now, we've seen lots of these in various styles. This is my tapered jig. This rides. There is no guide slot piece on the bottom here. This rides against the fence, and my work. Actually, I should probably just put this on the table so I can show you how this works. Here we have the piece. I would redo this if I was to build it again, but it has served my purpose. But here we have the piece, and if I want to cut a taper, I need to move my clothing. If I wish to cut a taper on this piece, I will swing this out to the taper that I want and run it through. I have marked various positions: 0, 10, 20, was it 22 and a half, 30, and 45 degrees along this bar, so I can adjust my, and it's pretty accurate. Set it once and forget it. There we are, 10 degrees, which is usually 7 to 10 degrees if I'm doing a tapered leg on a table or something. So pretty simple. There's a bunch of ways to do that. So this is made from reclaimed wood. Actually, this was the back of a chest of drawers, I believe, that somebody made. I usually leave this crosscut sled on my saw just to protect the tabletop, so it kind of lives there all the time. Coffee, very important. Now, my crowning jewel, as far as wood shop jigs and fixtures go, is my router table, my router fence. And we made the whole router table, starting with the laminated top and oak, red oak for the fence, and red oak underneath, and there's even some red oak under here. The red oak that surrounds the router to give a little support to the middle of the table. And the unique thing about this, what I've never seen in any other router table, is that this table maintains its parallel orientation. If you slide this back and forth from one end, just grabbing it at one end and giving it a shove, it stays parallel, because if you notice these strings here, these strings work very similar to the way you may have seen in on a drafting table, where you have a parallel rule. that stays parallel to the top and the bottom of the table. And it's very simple how this works. And that is, the strings are anchored at 4 points. 1, 2, 3, and 4. This screw here allows me to make a slight adjustments to the angle of the fence if I need to zero it out. So that just allows these strings to slip a little bit. Once I lock that screw, these strings maintain the parallel orientation of the fence. It's very simple how they work. The string starting here goes up over the pulley, across, and up to that point. And that string it does not stretch. This is a nylon covered type of steel string used in the fishing lures. I guess the leaders. And it can't stretch. And so that point and that point are fixed in terms of their relationship in this distance. So this whole fence cannot pitch this way. Similarly, from this point around this pulley over and down to that point, that string prevents it from pitching the other way. It cannot pitch the other way because the string would have to stretch to do so. The tension is kept by a spring here, and it works very well. And the advantage of that is, what really makes that so nice, because it really doesn't matter that much that you have. I mean, it's a single point, rotating cutter. I mean, it's as long as you can adjust the distance. But what's nice about this is that I can, from one end, let me tighten this up, a little wing nut. Okay, this is 50 thousandths per turn. It's a 1/4-20. I have a little calibrated brass wheel here with graduations marked on it, so I can turn this 10 thousandths at a time, and you see it move. So I can see if I can see the graduations here. Here we go. So I can make little increments. I can make small changes, and that's really nice to be able to make those small changes over here and have them equivalent change over here for things like sliding dovetails, like you saw on that cutoff jig. And so now what I've done on the front of this is I have various attachments. I have T-slots. We have a T-slot in the front, in the face, and we have a T-slot on top. So this sacrificial face here is just there to make sort of like a miniature horizontal jointer. I put one of those tall edge cutting bits, like a door trim bit, in here, and I put a shim behind the outfeed fence, and I set the cutter to the outfeed fence height, and so I can joint small boards on here. I do have a jointer, but if I don't want to pull that out and get that set up, I can just set this up as a jointer for small stuff, which is pretty convenient. And these slide out of the T-slots. Get rid of this. And then the next thing I have for the T-slot is just a simple stop block. So stop blocks are certainly easy enough, and that's a little thumb screw, tightens it up, and so now we have a stop block if we want to do stop dados or just all kinds of things. It's just nice to have a stop block set up and I have two. I don't know where the other one is, but it's not far. So I can put one on each side, just stop blocks. And then let's see, on top, for if I need to work on the ends of a board, I have this piece. Get it in there. I can clamp my work to this vertical piece, and I can make cuts on the end of a board. And before I had my, I have a lead dovetail jig that I like very much. It's a D24. But before I had my dovetail jig, I would do my dovetails on here, and that was a lot of. It was tricky. It wasn't easy, but at least this took a lot of the variables out of it. Being able to clamp it, and then I just use my ruler over here to set my spacing for my dovetails. But it's a lot easier now to use the dovetail jig or cut them by hand, which I've actually learned to enjoy. Depends on how many I need to do. If I'm doing a whole rack of drawers like I did here, where I've got the front and the back of 7 drawers, and I just really wanted to bang this out. This is my tool cabinet. I guess we might be able to include this under Jigs and Fixtures for home shop stuff. I needed someplace to keep all my tools, so I got all my planes on top, planes and draw knives and various devices and chisels and files and more planes. I have lots of planes. I like planes. Yet more planes, files, things of that nature. And not sure what I'm going to do at the top yet. If I want to do vertical pullouts, I might put all my planes up there. I'm not sure yet. But this has a camber door, so it looks kind of nice. And I may yet screw some kind of faces on those drawers. Haven't decided yet. But anyway, this is my vertical tool chest because I ran out of horizontal space. I'd love to have one of those hanging wall tool racks, but I just don't have enough wall space anymore. And the 2 planes I use the most usually just sit right here on my fence, and I'm always fetching them. When my router table is not in use, it works very well to hold various shop tools. So I'm just gonna place these over here. These usually live right here, and my router gauge. So that's my router fence. Okay, moving on. This is another jig that I'm fairly proud of. Let me spin this around and get a look at it from the other side. This is my box joint jig, and this works very much like a full crosscut sled. I have two miter gauge slot guides on the bottom, so it really maintains parallel. We don't want this. We want this to stay quite nicely in position when we're using it. So I can do 2 mating pieces. I can do multiple mating pieces at a time here, but one piece will go right up against the fence, so that will be the first cut, and then I'll use a spacer of whatever pitch is appropriate for the next piece to go in on top of this, and then clamp them down and make my cuts. And to advance to the next cut, I have a crank over here, which obviously is, again, 1/4 rod, 50 thousandths per turn. So 1/8, 1/4 inch. They're really, it's pretty simple to figure it out. And to eliminate the backlash, I have 2 T-nuts back to back here. This T-nut floats. It's just on a little floating piece. with a spring between them, so that it takes up the backlash. It keeps constant tension on this nut, so that I get an accurate adjustment. So if I want 1/4 inch, I can just, you know, go 50, 100, 150, 200, 250, and we're at 1/4 inch. And obviously, to do a 1/4 inch pitch, it's a 1/2 inch pitch. Actually, 1/4 inch. This would be 1/4 inch. So it's a 1/2 inch between. So I'd have to turn this 10 times, and I'd have my 1/2 inch. And it's quite accurate. Works very nicely, makes nice tight box joints. And let me get the saw that I like. Some of you may cringe. I use an adjustable dado, and I find I can dial it in much more accurately with an adjustable dado than I can with a stack dado. Stack datable is easily resettable, but doesn't quite give you the variability. And I find that if I'm doing a softer wood, I'm frequently doing pine, and every once in a while I'll do something a little harder like maple or oak. But this does have to be tweaked. The harder woods will give you a tighter cut, whereas the soft woods will open up a little bit. So this, for pine, I may have to go actually a little bit under 1/4 inch on this adjustable dado to actually get a 1/4 inch spacing. And once you get it dialed in, it's really nice. And I have found this is not, you know, what I don't think anybody would consider like a real, you know, high quality brand, but it really does the job very, very well. I find it extremely repeatable. Very stable, very accurate. Once I get it dialed in, it's good. It's easily dialed in. It doesn't seem, you know, it doesn't change settings from one use to the next. And I got it on sale. I got it, as you can see, it was $53, and I got it for half that. It was on the closeout table at the Ace Hardware. So I really like that. In fact, this probably should just live in here because I don't use it for anything else. I also, for 1/8 box joints, I did find a carbide toothed blade that has square blade tips. They're cut square, and it was very difficult to find. And when you go into the store and you tell them what you want, they look at you like, huh? And you know, you have to explain to them that you're cutting joints. You're not cutting through a piece of wood. You're just cutting a slot. You want a square bottom. You don't want you know, a forked bottom where they alternate the angle of every other tooth. And anyway, so I use that for the 1/8. Okay, I might be remiss if I were not to mention that fact that you can and should make your own inserts. This is my Dado insert, which I've obviously used for several different size dados, as you can see from the size of the slots. This is my zero clearance insert, and it's nice and shiny because I like to wax things. And I shimmed it. I just shim it with tape to bring it up flush with the tabletop as needed. And that varies from season to season. Sometimes I'm peeling tape off, and sometimes I'm adding tape, depending on summer or winter. But it works just fine. And of course, the standard insert that comes with the machine, which has Allen screws in it for adjusting the height. So yeah, inserts. So near as I can recall, that's about it for jigs and fixtures. I hope you enjoyed that, giving you some ideas. And we'll see you in our next video. Thanks for watching.